In this video we're going to look at graphing quadratic functions, and I'm going to go ahead and do this in terms of functions, but you wouldn't have to do it in terms of functions. So let me show you what I mean. We're going to start with the most basic quadratic function, which is f of x equals x squared. So as I was saying, you wouldn't have to do this in terms of functions. Remember, f of x is the same as y, or if you're not familiar with functions, you can just substitute a y anytime you see me using an f of x, and that means the same thing. Alright, so let's go ahead and graph this. If you're not familiar with this, this is definitely something that you want to memorize and be able to produce quickly. So we're just going to do this with a series of x values and y values and plot some points. So let's have x equal 3, 2, 1, 0, negative 1, negative 2, negative 3, and plot these points. We're going to take our x values and plug them in for x and figure out what y is. So basically we're just squaring. X squared is going to give you y, or x squared will give you f of x. So 3 squared would be 9, 2 squared would be 4, 1 squared would be 1, 0 squared is 0, negative 1 squared is 1, negative 2 times negative 2 is positive 4, negative 3 times negative 3 is positive 9. Alright, so let's graph this. Our first point is 3, 9. So we'll go right 3, up 9. And then we have 2, 4, 1, 1, 0, 0, negative 1, positive 1, negative 2, positive 4, and negative 3, positive 9. Alright, and so if we connect these, we get this shape here, which is called a parabola. When you graph a quadratic function, you're going to get a parabola. So what makes something a quadratic function is basically if it has an x squared in it. The general form of a quadratic function would be f of x equals ax squared plus bx plus c, or y equals ax squared plus bx plus c. And these a, b, and c values are going to be your coefficients, so they're going to be numbers. And if you're working on something like this, you're probably, well, maybe getting to use the quadratic equation, in which you would also be looking at something of the form, an equation of the form ax squared plus bx plus c. Alright, well, let's go ahead and change this slightly and look at what happens if we change the graph or the equation slightly. So let's say we have f of x equals x squared plus 1. Okay, there's a new equation. We'll do this one in green. And we'll do, let's just do, for the sake of time, 2, 1, 0, negative 1, negative 2. So we're going to take 2 and plug it in for x. So 2 squared plus 1 is what we're doing. I'll go ahead and write that down. 2 squared is 4 plus 1 would give me 5. 1 squared plus 1 would be 1 plus 1, which would be 2. 0 squared plus 1 is 1. Negative 1 squared would be 1 plus 1 would be 2. Negative 2 squared plus 1 would be 4, plus 1 would be 5. And you'll see this pattern with parabolas here. Your y values will be the same for two pairs of points, and that's because of the symmetry of the parabola. Let's graph these and see what it looks like. So 2, 5 is right there. 1, 2 is right there. 0, 1, negative 1, 2, and negative 2, 5. And so what I want you to look for here is how, and this kind of, I probably should have made it a little bit more. This is going to be tough to draw. How does the graph of the blue parabola relate to the graph of the green parabola? How are they related to each other? We know how the equations relate to each other. The blue equation is x squared, y equals x squared. And the green equation in terms of y would be y equals x squared plus 1. So they're very, very similar equations. The green one is one more than the blue one. And look at the graph. What does the graph show you there? Basically, it's the blue graph shifted up 1. If I took this blue parabola and just moved all the points up 1, I would get the green parabola. And that's not a coincidence. Okay, when you have something like y equals x squared and you add a number, all it's going to do is shift the parabola up or down if it's negative. So let's write that down. Let's say we have the graph of f of x equals x squared plus some number k. So in the case of the green parabola, the k value is 1. What that's going to do is it's going to shift vertically, so up and down, the parabola. Shift vertically, parabola, shift vertically specifies up or down. Okay, vertically means up or down. So it's going to shift it up if k is positive, and it's going to shift it down if k is negative. So with this little piece of information, and this is kind of something that you want to memorize here, how to shift it vertically, we could graph very quickly an equation that just has a vertical shift. Let's do that. Let's say I have f of x equals x squared minus 3. So notice this is almost the same as x squared, it's just minus 3. So you're going to take your blue parabola and you're going to move everything down 3. Now that's why you want to get really familiar with your basic y equals x squared parabola and the pattern of it. Because then you don't have to do this table every time, this blue table. I mean, you can if you don't remember. But basically, if I see something like f of x equals x squared minus 3, I'm going to see that it's going to move the parabola down 3. So I'm going to go down 3 and start here. And then I know if x was 1, if it was 1 to the right, it's going to go up 1. If it was 2 to the right, it's going to go up 4. Because 2 squared is 4. If it was 3 to the right, 3 squared is 9, so it's going to go up 9 from here, which would take it up to 6. And then just reflect those points over the y-axis, reflect them to the other side of the y-axis, and you can very quickly get this parabola without having to do a table at all. Because it's basically f of x equals x squared. It's this parabola right here, just shifted down 3 units. There's no reason to go ahead and do the whole table again. Alright, so let's talk real quickly about what the vertex is of all these parabolas before we go on to the next example. So the vertex of a parabola is the point, the bottoming out point, or if the parabola was upside down, it would be where the parabola tops out. So in this case, the vertex is 0, 0. What is the vertex of the green parabola? It'd be right here. So that would be 0, 1. And what is the vertex of the, I guess we'll call this brown parabola, which I didn't quite finish drawing. What's the vertex of the brown parabola? Hopefully you said 0, negative 3. So something else I want you to notice before we erase some of this stuff is that this k value corresponds to something in the equation, or something in the graph. Can you see what that is? This k value on my brown parabola was negative 3. Notice that corresponds to the y value of the vertex. What was the k value in the green parabola? What's in the k spot? It's negative 1. Or, I'm sorry, positive 1. What is the y value of the vertex? Positive 1. What's the k value on the blue parabola? Y equals x squared. There is no k value, right? So it's basically plus 0. Plus 0. That's the k value. What's the y value of the vertex? 0. That's not a coincidence either. Okay, this k value is going to be the y value of the vertex. And we're going to look at a horizontal shift here in a second. If there's no horizontal shift, then the x value of the vertex is 0 because it's right on this y-axis right here. Okay, let's go ahead and look at a horizontal shift. Let me erase some of this stuff. I think we'll keep that, a little piece of information. And let's move in a new graph. Okay, so remember your basic parabola. You always want to remember that. Let's go ahead and draw that here. So remember 0, 0, and then 1, 1, 2, 4, 3, 9, and then just reflect it over. -1, +1, -2, +4, -3, +9. Okay, I didn't quite get down to my vertex there. There we go. Now, if you want to do a horizontal shift of a parabola, that's going to look like this. This is a little bit tricky with the sign. Let's say you had x minus something in the parentheses. I'm not going to add anything at the end here. So this h value right here is going to shift your parabola horizontally h units. So the thing that's a little tricky about this is the minus sign. Let me show you what I mean. Let's say we have a function f of x equals x minus 2 quantity squared. Okay, what is the h value following this formula right here? What number is in the h spot? Well, the number that's in the h spot is a 2. It's not -2 because, or -2, because this minus sign is part of the formula. So the value of h is 2. X minus what? X minus 2. The value of h is 2. So that means it's going to shift it 2 units horizontally. 2 units, +2 units, so it's going to shift it to the right. Okay, if it was different, it would shift it to the left. I'll show you one of those in a second. So what this is going to do is going to take your basic blue parabola and it's going to shift it 2 units to the right, which is a little counterintuitive because you see this -2, so you want to shift it to the left. But because the minus is in the formula, you shift it to the right. It takes a little getting used to. Okay, so we're going to start here for our vertex at 2, 0, and then we're just going to build our basic parabola again from here. So over 1 up 1, -1 up 1, over 2 up 4, and -2 up 4, and then you could do the 3, 9 one, but for the sake of time I'll just graph that like that. Alright, what if I wanted to shift it to the left? Let's say I wanted to create an equation where I would shift the parabola 5 units left. Okay, so if I want to shift it 5 units to the left, that means I want my h value to be -5, because -5 is going to shift it to the left. My general equation over here that I gave you in this light blue color, f of x equals x minus h quantity squared. So I put my h value in for this h value, and what do I get? Let's see, f of x equals x minus, now my h value is -5 quantity squared. So I get f of x equals x plus 5 squared. See, it's kind of opposite of what you think. When I see this plus 5, that is going to shift my parabola to the left. That's going to shift it to the left 5 units. Okay, so we would go over 5 units to the left. That would be my vertex. And then I would build my basic parabola again. Over 1 up 1, over 2 up 4, left 1 up 1, left 2 up 4, and connect. And you could do the 3 and 9 one again to make it look a little prettier. So that's what happens in the equation that causes the parabola to shift left or right. Let's take a look at the vertex of these before we put these two concepts together. So the vertex of the green one, the vertex is right here, which would be what point? 2, 0. And the vertex of the brown one is right there, which would be -5, 0. And of course the vertex of the blue one is 0, 0. So what I want you to notice is this x value of the vertex corresponds to the h value in the formula, and that is not a coincidence. This x value of my vertex corresponds to my h value in my vertex. Alright, let's put all these concepts together. If you need to write some of this down, just go ahead and pause the video because I'm going to get rid of some of this. And we're going to put this all together. Oops, I don't want to do that. Okay, so we got our blue, light blue fact over here, shifting the parabola horizontally, and we've got our purple fact here, which is what shifts it vertically. And we're going to put these two concepts together and create our general formula, which is f of x equals x minus, I left a little gap there because for a reason, x minus h quantity squared plus k. Alright, what if we have both of these things going on? We have an h value and a k value. Then we're going to have a shift vertical and a shift horizontal. And our vertex, we know the x value of our vertex is h, and we know the y value of our vertex is k. So the vertex is going to be at hk. Alright, let's pull this in here. Alright, so let's say we have an equation, f of x equals x minus 3 quantity squared minus 4. So the first thing you want to do is realize that this is a parabola. Obviously I'm talking about parabolas, but if you were just doing this amongst a bunch of different graphs, this squared, the fact that the x is squared tells you that this is a parabola, and this is in this form. This is our general form, f of x equals the quantity x minus h squared plus k. Let me go ahead and tell you now why I left that little gap. There's another number that can influence what the graph looks like, another value, and in the formula we're going to call that value a, and it will correspond directly to this value a right here if the equation's in this other form. These two equations are forms of the same equation. If I took this x minus 3 and squared it, x minus 3 times x minus 3, and FOILed it out, and then minus the 4 and combined like terms, I would end up with something that looks like f of x equals ax squared plus bx plus c. So these two formulas are basically the same, just different versions of the same formula. And sometimes you'll get an equation in this form and sometimes in this form, and going back and forth between these two forms is a whole nother topic. But you would want to be able to go back and forth between these two different forms, or know how to find the vertex from these two different forms. And in a different video, I'll talk about how to find the vertex quickly if it's in this form, ax squared plus bx plus c. If the parabola is in the form a x minus h quantity squared plus k, then the way you find the vertex is simply by looking at what are the values of h and k, because that's your vertex. Now this a number, which in our case for this purple parabola, if there was an a value there, it would just be 1. And what that 1 is telling you is it's just your basic parabola, that blue parabola we did at the very beginning, y equals x squared, which is 1x squared, or f of x equals x squared. Okay, the fact that this a value 1 corresponds with this a value 1 tells you that the parabola is the exact same shape. It's not any wider or skinnier. And if this a value changes, you get a wider or skinnier parabola, which I'll talk about in a different video. Okay, so what is the vertex of this purple parabola? That is the question. See if you can come up with that. Alright, the h value is 3. Because there's a minus in the formula, x minus h. X minus 3. So the vertex is 3. It's not negative 3, it's positive 3. What is the k value? In my formula I have a plus k, but in my equation here I have a minus 4. So minus 4, that's the same as plus a negative 4 if I want to make it look exactly like my formula. So that means the vertex is negative 4. I'm going to go ahead and plot my vertex, which would be over 3 down 4. And then because my a value is 1, I know that this parabola is going to look exactly the same as y equals x squared parabola. It's just shifted. So from 3, negative 4, I'm going to go over 1, up 1, over 2, up 4, and just create this exact same shape. Over 2, up 4, and I could do the 3 and the 9, but I'm not going to do that. Okay, and there it is. Very quickly graph that equation without having to do a table or anything like that. Let's do one more, and I'll give you one and maybe pause the video and see if you can draw a quick graph of it. Let's do f of x equals x plus 4 squared minus 2. So go ahead and pause the video and sketch a graph and start it when you're ready. Okay, so the first thing you want to do is identify the vertex, which is h and k. Your h value, x minus h, but here you have an x plus 4. So this is x minus what? It's x minus negative 4. Basically, you're just going to take the opposite sign when you're doing this x part with the x minus h. If this is a positive 4, your h value is negative 4, and vice versa. Your k value, in the formula it has a plus k. Here we have a minus 2, so your vertex is negative 2. Okay, so we're going to go negative 4, negative 2. There's our vertex, and then we build our parabola. Up 1, over 1, up 1, over 2, up 4, left 2, up 4. Did I go up 4 there? Yeah, okay. And then sketch it in. And that's it. Alright, well, I hope that helps give you an idea of sketching your basic parabola and finding the vertex. This is a formula you're going to want to memorize, including the vertex part of the formula. And in the next video, we'll talk about what A means.